Hi guys, I'm Nikhil and today we are going to talk about the complexity theory. So, in complexity theory, there are major categories in which the problems are put. There's the first category is P, called as polynomial time. So, when a problems, it consists of all the problems whose decision version is solvable in polynomial time. So all the problems whose decision version is solvable in polynomial time, uh, all of them belong to the P class, that is polynomial time class. Another class is NP, that is non-deterministic polynomial time. So it consists of all the problems whose verification version is solvable in polynomial time. The third major class is also the NP complete class. We can come back to the NP complete class to understand more in detail later. To know about the NP complete class, we have to know few things before that. So let's take an example of a traveling salesman problem, which is an NP complete problem, in fact, or we can say a circuit satisfiability problem. So let's take only this traveling salesman problem for now. So what the traveling salesman problem is that you have given a graph. So graph consists of vertices and edges. So let's take an example that we have this four four vertices A, B, C, D, and let's say it's a fully connected graph, that is each and every vertex is connected to each and every other vertex. And so the maximum number of edges that a graph can have is only when the graph is fully connected. So here we have four vertices and 1 2 3 4 5 6 edges, and the aim of the traveling salesman problem is to find a path such that we start from a vertex and we visit each and every other vertex and we come back to the same vertex where we started, and this path has to be minimum. So this is the traveling salesman problem. So if we consider this graph, the possibilities of number of edges can be, like, if we want to solve this traveling salesman problem, we have to then the first thing comes into our mind is we evaluate each and every such path. We find out each and every such path along with its weight, or along with the value of such traversal from one vertex and visiting every other vertex and coming back to the same vertex. So let's say we can start with A and find out all the paths that exist for vertex A, starting with vertex A and ending at the vertex A, visiting all the vertices, and we do this for each and every other vertex. And then so we have all the paths along with their values or their weights, and then we find out the minimum from it. So this is a brute force approach that comes into our mind, and it is in fact the approach that only exists. So even if we want to apply the brute force approach to find all the possible permutations and take out the minimum cost path from it to solve this traveling salesman problem, let's see how much time we will need to evaluate all these paths. So let's say that we have this 1 2 3 4 vertices, and the maximum number of edges that we can have is 6, and that is because this is fully connected graph. So we can have different kinds of paths like A, B, C, B, and then A, then A, C, B, D, then coming back to A, then A, B, C, D, then coming back to A. If you evaluate all of this, you can say that there exist A, D, C. So there exist like this many combinations: 1, 2, 3, 4. So this can take value of like 1, 2, 3, 4, 4 factorial, 4 times. I mean, if you consider the uh, theory of probability and the combination and permutations, you can say that this place can be filled with 4 different possibilities. The next can be filled with 3 different possibilities. The next can be filled with 2 different possibilities, and next can be filled with 1, which is remaining. So in fact, there are 4 factorial different paths that we will have to evaluate to find the least cost cycle, or to solve this traveling salesman problem. So since there are 4 vertices, we at max, considering the worst case possibility and considering that the graph is fully connected, we will have to evaluate 4 factorial different cycles. So if we have n vertices, we will have to evaluate n factorial different cycles. So n factorial is something very big, and which is even more than exponential. We can say that the time complexity to calculate all this is huge, extremely huge, which is n factorial. So this is something non-polynomial. So this is the traveling salesman problem. Now let's come to our main motive, which is the considering the time complexity theory or the complexity theory. So if you consider that you have found out some way to find the shortest path for the traveling salesman problem. So let's say this is your algorithm to find the shortest path for the traveling salesman problem. Now here in this traveling salesman problem, you are trying to minimize the cost of the cycle which you are going to find. So this is an optimization problem where you are trying to either maximize something or minimize something. So these kinds of problems are called as optimization problems. And so this version of this traveling salesman problem is the optimization version of traveling salesman problem. So let's say that this is the optimization version, and you have found out some algorithm to find the minimum path. So input to this will be a graph, right? And you will get, let's say, the length of the minimum path which you have found. Now this is the optimization version. Now can we convert this into another version, which we can say that a decision version? Now let's say if we can convert this into the decision version problem. So what we can do is, consider we have this decision version of traveling salesman problem. What this decision version does is, when we are giving some length to it, and of course we are giving the graph as an input to it, length L1, let's say. So what it does is it compares the length of the shortest path which is found through this insider TSP optimization version, and gives us either yes or no, or true or false, that the given length is greater than L1 is greater than the length of the shortest path or not. So we have true or false from it. So we can say that if we have, let's say, if we enter some value starting from, let's say, 1, and we keep on doing that, keep on increasing the value. For 1, if we input 1 length here, and if we get the output as false, that this L1 is not greater than L, and we can keep incrementing this length till we get the answer as true, and that will be the length of the shortest path we can find. So this is the decision version. So we found out a decision version of the problem for traveling salesman from its optimization version. So this is how we evaluate, or how we convert the problem into various categories like optimization, decision. And the another version is the verification version. Now consider that you have given a graph, you have given the edges, and you have also given one candidate path, and you have to check if the path is having the is in fact indeed the shortest path of the traveling salesman problem. So you can find out that also. So with the same input, this is the Tsp verification version. You have given the graph as input, you have given a candidate path as an input, and now what it will do is it will evaluate the candidate path, and it will see if the length which we have got from the optimization version is in fact equal to the length of the candidate path, and it will give us either true or false, that indeed the provided candidate path is the shortest path or not. I have not shown that in the clear manner, but you can understand that we just have to evaluate the candidate path, traversing all the nodes and calculating the length of the path, and you just have to compare it with the length of the path provided by this Tsp optimization version algorithm, and if it is matching, then you have to output as true or output as false. So these are 3 kinds of versions a problem can have, and P, that is polynomial time problems, consists of the P category consists of all the problems whose decision version is solvable in polynomial time. So all the trivial algorithms like sorting problems or any other problems comes into this category who are solvable in polynomial time. And NP category is a category of the problems whose verification version, that given a candidate answer, you are able to verify that it is indeed the correct answer for the problem or not. So you can verify easily in polynomial time the given solution for the given problem. So this is the NP category. So this is about P and NP. Thank you.